Hello, welcome to Tech Transform. Today we are here to discuss about visualization library, third package library called Matplotlib. So very useful in data science. In couple of previous videos I have covered NumPy, pandas, and this is the third one, Matplotlib. So this is a plotting library written in Python programming language, and it's numerical mathematics extension NumPy. You can generate plots like histograms, power spectra, bar charts, pie charts, uh, with using scatterplots, subplots using Matplotlib library in a very single or some line of codes. So let's get started. The very first thing we have to do is Matplotlib. We have to install this package. If in your case it's not available, go and type file, new tab, pip install matplotlib. Okay, after installing you have to import in your Python file like this, import matplotlib.pyplot as plt. And remember one thing also, this is we are going to cover one more library in my next session, that is called Seaborn. That is very advanced version of that, and that is very useful right now. And you can get a lot of good picture representation, visual representation of the data using Seaborn. So that's the advanced version of Matplotlib. So this how we are able to import. Then the second line you are seeing is %matplotlib end line. This line you have to write it because if you want to, let's say you want to show the plots here, these plots inline here, you have to write this. Otherwise you have to, every time you have to type plot.show in every plot if you want to plotting. And we are going to use NumPy here, so that's why I'm importing NumPy also. Import NumPy as np. You can see this x is equal to, I'm taking two values because we are going to create a plot. For that I need 2D plot. I need x-axis and y-axis. So x coordinate and y coordinate you can treat as this is x coordinate, this is y coordinate. So this is nothing yet. I am taking that np.arrange method. It is going to give me value from 0 to 10, excluding 10 means 0 to 9. This will give me value of starting from 11 to 21, excluding 21. I am taking another variable a and b which I will be using in future. So the very first plot is coming here is a scatter plot. A scatter plot is basically you have to give the alias name plt dot scatter. So using plt dot scatter, basically you can print the scatter plot. A scatter plot is basically it's scattered means you won't find there are connections. So that's what it will print every data points like that. So here if you can see what is the value of x and y, print x, print y. So see, we have x values 0 to 9, then corresponding for x0 y is 11, for x1 y is 12, for x4 y is 14, like this. So you can say for x0 y is 11. If you don't give this, this will give you a plot like this. So these are the, if you want to see what are the parameters available, shift tab. There is a very good documentation provided here. Once you hit shift tab, then you're able to see this is the x coordinate, y coordinate. S means what type of line, what type of a scatter plot you are to print. You want to solid, you want to dash, or something like that. C is equal to color. C is for color, that's what I've used here. G for green. I want to specify. Here you can see list of colors also available. Once you go down, what are the colors available here? So it's a very nicely written document. We can utilize that. So see, if you're not giving this C parameter, by default it will take blue. If you want to change this, C is equal to, let's say, G. So you're able to see in a dotted line that color is green. Let's say you want to display like this, hyphen hyphen dash dash. 1 second. So that will be look in the next example. So this is how you can change the color to Y, and you can get in yellow color. So that's how the scatter plot. Let's say this was the straight line. I don't want the straight line, and I want the different variable. Let's say curve type of thing. So for that, what I am going, the x values I am keeping remain same, but y value I am taking x square, and then again I am try to so this was the scatter plot. Okay, this is the plot. This was plt.scatter. Also, yeah, one thing I didn't tell you. Let's say this is x-axis, this is y-axis. I want to specify explicitly here x-axis as a label, y-axis as a label, and I want to give this whole graph a new name, like graph in 2D. So we can use plt.x label for x-axis label, plt.y label for y-axis label, and I want to give title as a whole. So see, we got this x-axis here, y-axis here, graph in 2D. Cool. The next one is plot. So scatter plot is just a dotted line. Let's say I want to play with the curve type of line. For that, we have a plt.plot, x-axis, x value means y-axis value. Y-axis is nothing but x square. G is green color. If you don't want to give like this, you don't give right now. Let's see what is the basic example. You can see this is the straight line. If you want to give something like hyphen hyphen, it will come like this. If you want to give star hyphen, it will be combination of star. This is the stars. If you want to replace, if you want to give double dash, so see there are different lot of combinations available. If you want, you can check in the documentation here. So let's say so this is another way to give the line style as a dashed. This is if we want specifically this for color, then we want line style as a dashed. So it is coming as a dashed size. Okay, I haven't executed this y equal to x square. Now again execute this. That's why we are giving a straight line. So see, this become curve. Okay, pretty cool. See, I give plus, it become plus. So you can draw, use lot of combinations here. The next part is this is plot. If I want to display more than one plot, let's say subplot. Let's say this is the area I want to display 4 plots, 5 plots, 6 plots. So that becomes the concept of subplot. If we want to display subplot, the how to display subplot is plt dot in here we were doing plt dot plot. Here we have to do first plt dot subplot. Then the very first parameter is, you can see n rows n cols, means how many rows, how many columns you want to divide your subplots, and index, the position where you want to, because let's say you have given 2, it means you have divided your whole plot into 2 into 2, means you have four places where you can put your subplots, and index is the position where you want to put that plot. Let's see this in action. See here I am telling that 2 into 2 means subplot, 2 rows 4 columns. See, 1 row, second row, 1 column, second column. So this I am telling put, because I got 4 spaces, means plot is divided into 4 parts. Now in these 4 parts I want to display subplots. For that I am giving x, y. So this is the first position. This plot, this line is going to print this subplot. This subplot is in second position, means this one. So this is going to print here, and this is going to print here. So this is not, this is just if you want to display it some, let's do in a basic way. If you want to do like this, see how this come. So this plot, see, it's in 4 position, 1 2 3 4. Let's say I want to make it as a third position, so I have to simply change this one. Okay, so this is the concept of subplot. Let's say you want to fill the fourth part also. Control V, change this position to 4, tell this value to something bg. So this white I have given, so it will not print. Okay, so this is how we consume. If you want to increase the subplots, you can change your n rows and n columns here. Okay, so this is another way you can do, like, let's say your x value is like this and your y value is following some equations, let's say linear equation, and anything you want to print that y value. For that is also supported, means y is here calculative, 3 into x plus 5. Based upon that, we are printing the this plot diagram. Okay, the next thing is we can display these plots not only in straight line or curve. We can create sine function and cosine function and create the sine wave or cos wave. Let's say I am taking a value x-axis value as a np.arrange. What it is doing, it's starting from 0 and it's multiplying, doing 4 into np.pi. np.pi is nothing, just 3.14, 22 by 7. So its x is starting from 0 up to this value, then its step size is 0.1. So if you want to see the value, I can show you. Print what are the values here. X, see, these are the values starting from 0, it's going up to this and taking the step size 1, 0, 0.1, 0.2. Okay, and y value is nothing, it's np.sine. So what it is going to do, it will take all the value from the x list, NumPy array. Each element it will apply sine function and will give you the sine value of that. Then I am trying to plot this, so this is going to take this shape, so sine wave. Same I want to do for, let's say, sine and cosine, both I want to see in a single plot. So I am going to create subplots. So let's say my x value is np.arrange this, and y sine is sine of that particular x, and y cos is cos of that particular x. Then I am creating a subplot. I want to print only 2 subplots here, so that's why I have given the dimension here is 2 rows 1 column. So that's way it can fit only 2 subplots. And this is I want to print in the first position, and the plt.plot is x and y sine. So this is the sine function, and this is the cosine function. Both the waves I am printing here. So this output, this will give you this second output. Okay, this you can do a lot of different thing, a change you can do like this also. Okay, you can change color. Okay, bar plot. So bar plot is nothing, it's just give you a pictorial presentation how it's, see, this is how it's working. Let's say I have a value of x 2, 8, 10, corresponding y value 11, 16, 9, and again I have a x2 and y2. Let's say we have 2 lists and we want to compare these two outputs in a single plot. So we should use bar plot. See how it is going to work. So I have plotted plt.bar. So this is the method we are going to use to print a bar graph, x and y. This I am printing another plot, another bar graph of value x2 and y2, and color I am specifying G. So see how we are going to get. So x1 value is 2, 11. So x is 2, value y is 11. So this blue by default is coming here, by default color is blue of every plot. So you can see the x, you can see this x y, this is x2 y2 value, x y, this is x2 y2 value, something like that. So you can compare both those, how the data are varying. So that's pretty useful in exploratory data analysis. Histograms. So what a histogram is, let's say you want to take a value from range. Let's say I'm creating an array of these values. So these values must fall in a range. Let's say the minimum value is 5 and the maximum value is 87. So this whole array will fall in the range of 5 to 87. Let's say I want to print a graph where it is going to display the number of items in each range. Let's say for this we are going to use plt.hist. So this is histogram and it is going to take this value. See how it is going to get. You can say from it marked here 20, so 0 to 10 or 11, this you can see. So for range of 0 to 10, the number of counts. So let's say this is actually not 10, this is more than 10 because it's starting from 5, because lowest value is 5 and maximum value is 87. So it will give you the min and max. In between that, it is going to divide in a bins. These are called bins: one bin, second bin, 3 bins, 4 bins. So this is going to divide whole data in a bins, and by default the bins is 10. If you are not specifying bin size, it will take by default 10. So what it is going to do, it's going to divide from value 5 to 87 into 10 different splits, and each value it's going to provide you the number of counts. Let's say for this to this range, the values are the number of values are from this range to, let's say, 10 or 11, 3. From 20 to 40, if you calculate, this is 2, 3, 4. So total 4 values are present. So this will basically give you the whole representation of that, how your data is actually distributed, how many times, what are the range for this particular data, which data is falling into which range, and for particular range, what are the counts available for the data you have provided. So that's what the histogram is used for. You can specify bin size also. By default it's 10. By default, how I am saying 10, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's by default it's divided into 10 part. Now it's divided into 20 parts. 5 to 87, now it's divided into. So that's what your bin got changed, so your number of counts got changed because your range got changed. Okay. Next, see what we are going to do. We are going to plot. This is actually insert cell Boxplot. Okay. So this is a Boxplot. How we are going to print Boxplot is it's very useful when you are in a statistics, when you are try to divide your data and you want to correlations between data. So you want to identify the outliers in your data. The Boxplot is very useful in that. How we are using this is the list comprehension way to print the result. So this is what I am taking a range is starting from 2 to 6. There will be a 4 value 2, 3, 4, 5, and for each value what I'm taking a random value and try to normally form a data. Means this will give me np.random.normal. It will give me the normal distribution of data starting from 0 to 2, and the step size is 100. So it will take 100 steps and it will give me the normal distribution of data. And if you want to print this, if you want to see this data, you can see. see these all these datas are available. So basically 2 3 4 5 6 2 3 4 5, so it will be containing 4 list. Each list, see how the data is coming. So normal distribution, so data will be distributed normally. So that's why we are using here np.random.normal, normal distribution. Okay, to print the box plot, the syntax is plt.boxplot. First you have to provide this data. Okay, the data you have to provide, then word equal to true. If you not specify this particular parameter, let's say I will delete this. So color will, so vertical, so it become, your whole data become horizontal. So that's what vertical and horizontally you can switch your box plot. And patch art is equal to true. If you make it false, it will not give you any color, so that's why I kept it as true. And you can see these is called a quartile range, percentile range. So this is 0 to 25 percentile, this is 25 to 50 percentile, 50 to 75 percentile, 75 to 100 percentile. These are also again same, 0 to 25 percentile, 25 to 50, 50 to 75, 75 to 100. And these are the data you are seeing. These are basically the outliers. So using Boxplot we can basically find how many outliers we have present in the data. The next is the next and the last diagram we are going to print here is pie chart. So for that you have to take tuples, like you can specify like this tuples, or also you can simply give a quotation comma. So I have 4 labels. Let's say I have given big data science, Hadoop, Python. So these are the actual sizes. So let's say big data is going to take 115. Let's say you are specifying the number of students of big data 215, data science 435, Hadoop 567, Python 100. So what it will be going to do, it will going to add this total value and find a sum. Let's the sum of these all items become, let's say x. So this 215 is what are the percent of x, this 435 what are the percent inside that, 516% is what, 100 is here, how many, what are the percent is going to take in a circle. So colors, because we have four labels here, so I have taken 4 different list of colors. Explode is like how you're going to separate your each area. So let's say let's say I want to specify, let's first see how you are going to print this. So plt.py, this is how we are going to print the pie chart. First we have to specify the sizes, this parameter, then explode equal to explode this variable, then we have to specify labels, then we have to specify colors. And auto packed is for how we are going to print this data in what format. So I want to print in a percent format and floating, so that's why I put here 1.1 f. Shadow equal to true, basically shadow is equal to c. Now you have a question, what is the explode is doing? Let's say I want to see there is no separation between this. If you want to explode is basically exploding your that particular part to outer. So that's what the, if you want to specify more, it will go beyond that. Okay, so that's what the explode parameter is used. 0, if you give 0 there will be no space. Shadow is equal to true, let's say equal to false. So this shadow you are seeing here, this shadow will become plain. See, there is no shadow. We got this. So based upon the value calculated, 215 is basically 33% of the entire cumulative sum. 435 is 16.3%, something like that. 567, 100. So data science is this 435. So this is for 33%. Okay. So that we have seen a lot of examples here to plot different plots: scatter plot, then the plots, then plot, then subplots, then different examples with the subplot. How we are going to print sine cosine function using subplot, then how we are going to print in a single plot and divide into subplots and print sine and cosine so that we can have a difference, we can find difference. Bar plots, we see histograms, we just saw box plot, also we saw pie charts. So that's all for this video. Thanks for watching, have a good day, bye.